This is the second question inside of the revision set for topic 3. A 5.5 kilogram block is set into motion up an inclined plane with an initial speed of 4.8 meter per second. The block comes to rest after traveling 1.38 meter along the plane, which is inclined at an angle of 22 degrees to the horizontal. For this motion, what is the coefficient of kinetic friction? Provided here is the hint. Firstly, we can calculate acceleration using kinematics equation based from information given. And the second information is about the direction of the friction force, which is opposes the motion. We're going to be using this kinematics equation Vf squared is equal to Vi squared plus with 2a delta x. So Vf is going to be equal to 0 and Vi is provided to be 4.8 squared plus with 2a, which is the unknown that we need to obtain, multiply with 1.38. So the acceleration is going to be negative 4.8 square over 2 multiplied with 1.38. So the acceleration is going to be equal to negative 8.35 meter per second square. So negative means that it is going to be opposite direction of the motion, and then it is clashing with the direction of the initial velocity. And because of that, the acceleration is going to be a negative acceleration, or in this case, it is deceleration. Now, drawing the free body diagram for this block. So I will start with drawing the inclined plane here, and I will put information regarding the angle between the inclined plane as well as the floor, which is going to be 22 degrees. So I will now draw the block here, and then I will start drawing all of the forces acting on this block. Firstly, I will start by drawing the weight. W is equal to mg. We're also going to have another force which is going to be normal because the block is on this inclined plane, and another force is going to be the friction force. Because the block is moving up the incline, the friction force is going to be opposite of that direction. So this is our direction of friction force. Remember that friction force is always opposite direction of motion. Okay, so another thing that we have to draw is going to be the acceleration, and the acceleration, if you can recall, is going to be downward direction. So acceleration has opposite direction with the initial velocity, and due to that, they are going to go against one another, or we can say that this is correctly negative acceleration or deceleration. Due to that, we can now tilt our x and y axis. So this is going to be our x and y axis. The reason why we tilt the x and y axis, because we want the acceleration to be in a single axis. And here the acceleration is going to be only on the x-axis. And then as you can see here, we have normal and friction force along the x and y axis. However, the weight is going to be having two components. So the weight is going to have two components, which is going to be firstly wy, which is here, and then it will also have wx. Okay, so this is the direction of wx and wy. Reason being is actually w is not exactly on the y or on the x-axis, and due to that it will have two components. And another information that we also have to configure is going to be the angle. Because this is going to be 22 degrees, what happened is actually on this corner, it is going to be 90 multiplied with 22, which is going to be 68 degrees. Okay, so what happens actually, WX is 90 degrees with WY. So the angle here is going to be also 22 degrees. So now we will apply Newton's law of motion based from our free body diagram as well as the acceleration that we have calculated. For the first one, we're going to start with for the x component, total force on the x component, and then it is going to be equal to ma. And then because acceleration is directed towards the negative x direction, it is going to be negative ma. All right, so moving on, we have the total force here. We're going to list down all of the forces that we're going to add, which are going to be the friction force as well as Wx. And then here, because again, they are also directed towards the negative x direction, it is going to be negative for both of the forces. And then we're going to add them because we have to find the summation of force acting on the x component, and then it is going to be equal to negative ma. So we can substitute the formula for the friction force is going to be mu n and then minus with, here it is going to be Wx. It is also equivalent to mg cos 98 degrees, and then it is equal to negative ma. We have the information regarding the mass, g, as well as the acceleration. However, we don't have information regarding mu as well as n. Mu is the parameter that we need to obtain, and can be obtained from derivation based from the y component of the force. Okay, so with that, we're going to use total force on the y component, and then it is going to be equal to 0 because there is no acceleration on the y-axis. The acceleration is only on the x-axis. Okay, so the normal n is going to be positive because it is upward, and then plus with negative wy, and it is going to be equal to 0. So n is equal to wy, or we can write down n is equal to mg sine 98 degrees. Okay, so afterward we can now substitute into the original formula, so that mu multiply with mg sine 98 degrees minus with mg cos 98 degrees is equal to negative ma. Okay, so now we're going to substitute the value. Mu is the unknown that we need to find. The mass is going to be 5.5 multiplied with 9.81 sine 68 degrees minus with 5.5 multiply with 9.81 cos 98 degrees, and then it's equal to negative 5.5 multiply with the acceleration is going to be 8.35. Okay, so definitely we can actually eliminate mass out of the equation because mass appears on each of these expressions. So the answer here is going to be negative 50.03 mu, and then minus with 20.21, then it is going to be equal to negative 45.93. So mu is going to be equal to negative 45.93 plus with 20.21, and then divide with negative 50.03. So mu is going to be 0.514. So this is going to be the coefficient of kinetic friction between the block and the inclined plane.